Hello everyone, welcome back. In this section, we will be focused majorly on the descriptive statistics. The main objective of this section is to understand the measure of central tendency, where we will be discussing about the mean, median, mode, and for which such kind of situation we have to use mean, median, and mode. And then we'll discuss about the measure of variability or measure of spread. There we're going to discuss about the range, interquartile range, variance, and standard deviation. And also we will be simultaneously looking into the data distribution, particularly about the skewness and box and whisker plot for understanding the spread. Alright, so without further ado, let's get started with the central tendency. When it comes to the measure of central tendencies, basically it will try to calculate the average. When it comes to the averages, we all know that there are three types of averages are there. One is mean, median, and mode. We know all the difference between how to calculate the mean, how to calculate median, and how to calculate mode. We all know the difference of this. In this lesson, I will be majorly focused on for which situation the mean is appropriate, median is appropriate for which kind of situation, and for which case the modes are being very useful. Okay, let's get into this. Let's take one scenario of health club. Let's say we have a Statsville Health Club, and this is the advertisement given by the Statsville Health Club. The Statsville Health Club prides itself ability to find the perfect class for everyone. Whether you want to learn how to swim, martial arts, and get your shape of your body, and this is the right class for you. This is advertisement given by the health club by Statsville, and assume that you are excited with the Statsville club and you want to join the Statsville club, and your age is 25 and you want to do the activity where you are actually find the same age group of yours, and your age is 25 by the way. Statsville Health Club is offering the three kinds of activities: martial arts, gym, and swimming. And you ask the receptionist what is the average age of the martial arts, gym, and swimming. She replied that 38 is for martial arts, gym is 20, and swimming is 70. And how we calculate the mean, and the formula of the mean is this is the symbol of the mean, which is defined by the mu, and which is sum of all values divided by the number of values. If you expand this, let's say we are having the n variables, and we will add all the n variables or n values divided by total number of values, and here we got the mu. And here basically this symbol is denoted by the population mean. You already know, we already discussed about this is the population mean. The formula is still same even for the sample mean. Sample means divided by x bar, and which is also same, which is summation of x divided by, basically this is the number of samples. And obviously the formula is also same even for the sample mean. Let's say this is my sample mean, and which is equal to x1 plus x2 plus so on xn divided by number of items or total number of values. Formula is still same. Alright, so we understand how we calculate the mean. Now let's get into the situation. Let's say you find this girl is very beautiful, and you enter into the gym class, and you find the different distribution of people, and you put it in a one table called age and what is the frequency. Frequency means how many persons are there with that particular age. And you found that at the age of 19, one person is there. At age of 20, 3 persons are there. At age of 21, one person is there. Now we calculate the mean, obviously, which is 19 into 1 plus 20 into 3 plus 21 into 1 divided by total number of people in the gym, which is 1 plus 3 plus 1. 1 plus 3 plus 1, and the value turned out to be 20. That's an average. And if you look into the distribution of the age and frequency, this is how it's look like this. Generally, any kind of distribution, if you see, and which will be represented in the two ways. One is histogram or bar plot. So in histogram or bar plot, we generally see the distribution of data. Let's say this is the simple bar plot of at the age 19, we found 1 person, age 20, we found 3 persons, age 21, I found 1 person. And if you look into the distribution wise, it's look like more symmetric, right? So equal number of people has been distributed equal in the both sides across the mean. Okay, that is the distribution of the data. Cool. Okay, now you found like, okay, none of the people of my age is 25. Basically it's your age is 25, and you find like none of the people are there of my age. Okay, let me go to martial arts and see what is the distribution of ages I'm finding in martial arts class. The moment you enter into the martial arts class, and this is what the age distribution of students we found. At age of 19, 3 students are there. Age of 20, 6 students are there. Age of 21, 3 students are there. And at the age of 145, the ancient old man, 1 person, and 147, 1 person. I think probably these two are friends. Okay, now what happens? What happens to the mean? I'm saying the mean age is 38. Now what happens to the mean? If I calculate this, 19 into 3 plus 20 into 6 plus 21 into 3, 145 into 1 plus 147 into 1 divided by total number of students, and the average age turned out to be 38, which seems very misleading, right? None of the people are in age of 38 or at least close to it. We have the distribution something like the people age is between 19 to 21, and at the extreme values with the people with the age of 145 to 147. But my mean is saying average age of the class is 38, which is completely misleading. Let's look into the distribution of the data, and this is how the distribution of data will looks like for me. At age of 19, 3, age of 26, and age of 21, 3, at age of 145 and 145, 1 each. Now, if you closely look into the data that 145 and 147, these are called extreme values, and in statistics, we call them as outliers. Outliers, in simple, this is the unusual trend or unusual behavior in the data. Let me give you the definition. Outliers are extremely high values, could be even extremely low values too, and standouts from the rest of the data. Basically, they do not follow the trend of rest of the data. If you look into the data here, or if you look into the average age of person, most of them are 19 to 21. But here we found the two ancient people who are the age of 145 and 147, and because of this, what happens? Our mean is got shifted. Usually if there is no people with the age 145 and 147, our mean might be 20, but because of these extreme values or extreme outliers, my mean is actually shifted towards the outlier, and probably this is what my new mean, which is 38. And if you look into that, none of the people are there in this age of 38, but because of this, our mean is got pulled towards this side. That's a big problem. And also you can see that the mean is actually has the effect of outlier. It will pull towards upwards or downwards. If you're having extreme high values, it will pull upwards. If you have extreme low values, the mean is actually pulled to the downwards. And this makes our distribution to get skewed. So if you look into that, the previously we have the nice something like this symmetry in nature, and because of this outliers, our data has been skewed to something like this, right? That is called skewed distribution. Okay, I have introduced some new term skewed. Now let's give you some idea of what is skewed. When it comes to the skewed, there are three kinds of distribution generally you will see. One is right skew, left skew, and symmetric. We already saw the symmetric. And the right skew is something like this. If you look into the tail, this is my tail, where you will actually find the tail. Basically, this is my tail. And at the tail, you generally find the outliers. Okay, so what it means, like if this is my left side and this is my right side, and the tail is usually observed in the right side, and in this tail you usually find the outliers. Because of this outliers, our distribution is got skewed towards the outliers, and because of this our mean will also shift towards the right side, and hence this kind of skewed distribution is called right skew. Now basically you can tell whether it's right skew or left skew based upon your tail. If the tail is on the right side, this is called right skew. If the tail is on the left side, this is the left side and this is the right side. If the tail is on the left side, this is called left skew. Basically this is my tail and I usually find the outlier in this region. Basically this is where the outlier present. So because of this outlier, what happens, my mean will shift towards the left side, and hence this is called left skew. And another kind of distribution we have is called symmetric distribution, where you don't see the where the tail on the left side and on the right side both seems to be equal, and the data distribution is very symmetric, and usually you find the mean in this range. Such kind of data is called symmetric data. Mean will perfectly work for the symmetric data, but however, mean has some disadvantages whenever the data is skewed towards right side and skewed towards the left side. That's what the limitation of the mean. Mean becomes misleading when the data is skewed with outlier. Okay, so then what is the solution for this? We have to go for the different average. That's why we have the three averages. The solution for that is median. Median is also known as the 50th percentile of data. Basically, this is the middle value. Okay, the median is always in the middle, and it is the middle value in the order of array of numbers. So let's say if you have some numbers out there, and in that numbers you arrange them in either in ascending order or descending order, our median will be the middle value in the order array. And obviously it doesn't have any effect by the outliers. Median is the one does not have any effect in the outliers. So how to determine the median? We all know that first step is arrange the data either in ascending or descending order, and then you end up with the two possible steps. One is the odd number of items. So if the total count is odd number, then the middle value is actually your median. Suppose if at all you have the even number of terms, then you end up with the two middle terms. Then in that case, the average is mean of two middle terms. Generally, the identification of the median we can easily identify with the formula n plus n by 2, where n is number of values or terms. Okay, so that's how we can identify the median. Now let's take this example of the martial arts. In our class we have the 19 people. In our class this is the distribution 19 3, 26, 21 3, 145 1, 145, 147 1. And here I arrange the data in the ascending order. Now if you see that in order to identify the middle value, what I can do is just identify the middle term. So let me cancel the first and last, slowly come to the middle part. Cancel this, cancel this, cancel this, cancel this, cancel this, and cancel this, and finally we end up with the two numbers. These are the two numbers is what we end up. Something like this. because we have even number of terms. You can even count it. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Since we have the even number of terms, that's why we have the two middle values. Now the median is, just take the two middle terms and do the mean of it, which is 20 plus 20 divided by 2, and hence the middle value is 20. That's perfect, right? We can see that's a perfect. Now we can say that the median of the data is 20, which doesn't have any effect towards our outliers. So basically this is my outliers and doesn't have any effect towards the outlier. Whenever your data is having the outliers, it is always recommendable to go with the median value. Cool? So that's the meaning of the median. And you can also easily identify the median, since I said that is we can actually identify the location of median by n plus 1th term. So here there are 14 terms are there. So 14 plus 1 by 2, which is 15 by 2, which is 7.5 term. So now we can directly take the 7 and 8, and we want the middle of this. Just take the 7 and 8, which is 20 and 20 divided by 2, and which we can easily identify that. And generally if we have the large number of data, and identifying the number of the term is easy, so we can easily identify the median with the help of this formula. Cool, right? Okay, again your age is 25, and it seems that none of the people of your age comes here. And but this is getting misleaded with the mean, because we have the extreme outliers. Cool. So again you find none of the people of your age are not interested, and you want to see how about the distribution of the swimming class. Okay, and if you see that the distribution of ages is something like this. We have age 1, 3 people or 3 kids, age 2, 4 kids, age 3, 2 kids, and age 31, 2 persons, age 32, 4 persons, age 33, 3 persons. The moment you look into the data, I know that what's your expression. What the heck? If you calculate the mean of this is 17, and the median of this, which is the middle term, which is 3 plus 31, which is 17. The mean and median both are misleading. How to deal with the situation? Oh my God. Let me give you one situation. Let's say this is the data. What if there is one more kid of age 1 joins this class? Then what happens to our mean and median? If you look into the median point of view, then basically it is n plus 1 by 2th term, and here we have the 21 terms are there, and which is the 21 plus 1 by 2, which is 22 by 2, which is 11th term. Our median suddenly become 3. The moment one person joins, my median is suddenly become 3. And how about the mean, which is summation of x by n, and if you calculate the mean of this, it will be 16.2. Okay, previously the mean is 17, and here I got the 16.2. Let me give you one more scenario. What happens if an adult with age 33 has joined the club? What happened to the data, and what happened to the mean and median? Median is again n plus 1 by 2th term, and there are 21 terms. 21 plus 2 by 2, 21 plus 1 by 2, which is 22 by 2, and which is 11th term, which is this. Now suddenly my median is become 31, whereas here my median is 3, and here my median become 31. And how about the mean? If we calculate the mean of this will become the 17.8. Okay, so one thing you need to observe is that median can lead to the large jumps, whereas the mean, the the variation is not much. Even if you add the extreme point at the end, or extreme point towards the downwards, extreme point towards the upwards, the median, or sorry, the mean doesn't have a certain jump, whereas the median has a sudden jumps in this kind of situation. So in this case, the median and mean will both fails, and median fails miserably compared to the mean in this kind of situation. Okay, if you look into the distribution of the data, this looks something like this. What happens here for this data, where our mean is 17 and the median is 17, what happens? We have the kid at age of 1, there are 3 kids are there, and age of 2 there are 4 kids, age of 3 2 kids, and age of 31 probably their parents, which is the 2, for that age of 32, 4, age of 33 is 3, and our mean and median are lies here. Okay, that's the data. So in order to solve the situation, whenever you're seeing some kind of data like this, and basically there are 2 cohorts of data or 2 clusters of data. I can say this is the cluster 1 data and this is my cluster 2 data. 2 clusters. This is my cluster or cohort, and this is my cluster 2, another cluster or cohort. Whenever you see some kind of a cluster or cohort of distribution of data, and in such situation, mode will work perfectly fine. Mode is a set of data and which is actually give you the result of highest frequency. And one thing you need to remember, that we can actually have the multiple modes in the data. It's not always like, we will have the one mean or one median in the data. In the mode, there is a multiple modes are possible because it is all about the highest frequency. Unlike mean and median, mode has to be the value in the data set. What are the mode you have defined, that value should be there in the data set. Then only we can define this. Whereas the mean and median is not necessarily that particular value, it should be there in the data. And mode will work perfectly both for numerical data as well as the categorical data. Both categorical data. And categorical with the highest frequency class is called mode class. And whenever you are having the 2 modes, and we call that the bimodal data. Okay, this is the perfect example of the bimodal data, because if you see, we actually have the 2 modes. Now when we look into the mode, we actually look into the highest frequency. Now here we identify the age of 2, there are 4 kids are there, and age of 32 there are 4 persons are there. Hence the mode here is 2 and 32. So this is the perfect example where you have the 2 modes, and this kind of data is called bimodal data. Okay, cool. That's how we can know where we have to use the mean, median and mode. Okay, now come to your age is 25. This is not at all your group. Either you're seeing a kids or seeing some parents. There are 2 categories of data here. And you will also not join this particular group or with this particular activity. Okay, so now if you look into the summary of this, but however you understand when you have to go for mean, when you have to go for median, and when you have to go for mode. In mean, basically the formula is sum of all values divided by total number of values, and particularly we can use this whenever the data is symmetric. If the data is having the skew distribution and having the outliers in the data, then it is perfect to go for the median. How you calculate this? Arrange the values either in ascending or descending. If you are having the odd number, then the middle value will be the median. If they have the even number of terms, then the middle value you have the 2 end up with 2, and you just divide the 2 divided by 2. That's it. And when it comes to the mode, it is actually the highest frequency. And basically this is particularly used whenever you are having the 2 or more clusters of data. In that case, the mode is a perfect example where you can use this particular average, and it will work for the categorical. If your data has categorical, you can use this data. Whenever your data have 2 or more clusters, you can use mode to represent the data. Hence, in summary, this is the Stat Valley Health Club, and what you can see is the mean is 38, which is completely misleading because of 2 Asian ones, and the mode is the best case for this because we actually have the outlet in the data. The mode is the best case, and what you have to understand is that the mode age, if this martial arts is 20, and gym, the data is perfectly distributed where you have the mean, median, mode or 20. Swimming class completely messed up the data where mean and median or both are failed, and so you end up with mode. So basically here the mean also failed. So where the mode is 2 and 32. Hope now you understand the difference between the mean, median and mode. Cool. So this is the idea of the mean, median, mode, which is the measure of central tendency. In the next lesson, we're going to discuss more on this measure of central tendency and their effects. I'll see you on that. Until then, happy learning.